I'm going to try to keep this one as short as I can. We're back to word problems. These word problems are going to involve factoring, but the standard way that we do them is the same. You start with a let statement or a sketch that defines your variables. Then you have to have an equation, solve the equation, and state your answer in a complete sentence. If we say the sum of two numbers is 16, let's go back to what that means. That defines two variables. Now I don't want to use x and y. I want to use, we'll say let x equal one number, and then if the sum is 16, then 16 minus x equals the other number. Because if I took them and I added them again, x plus 16 minus x, I would get a sum of 16. That's a good check to make sure that you have this part right. So then it says the sum of their squares is 416. Well, squares means the number squared. It means that we're going to take the one number and square it, and then we're going to take the other number and square it, and that sum is 416. So the first is just x squared, but then the 16 minus x squared we have to FOIL. That would be 256 minus 2 times 16 times negative x is 32x, then plus x squared. And if you have to go off to the side and write it like this, that's fine, but make sure that you're FOILing these two binomials together to get the trinomial. Equals 416. Now we're going to set everything equal to 0 so that we can solve this. So I'm going to simplify the left, 2x squared minus 32x plus 256, putting it in descending order, equals 416. Let's subtract 416 from both sides, and I get 2x squared minus 32x plus 416 minus 256 is 0. That'd be 160. So, and this is negative, so negative 160 equals 0. Let's take out a greatest common factor. I can actually divide both sides by 2. So I get x squared minus 16x minus 80 is equal to 0. And then I'm trying to take this and factor it with an equal 0. What times what is equal to 80? Well, 80 could be, we want them to differ by 16, so I'm going to start in the middle with 8 and 10. That's not going to get me to 16. Let's try 4 and 20. Okay, that's going to work. If I do x plus 4 and x minus 20, then that's going to FOIL to give me a negative 16. So I get x is equal to negative 4, or x is equal to 20. Now, here's the important thing. If x is equal to negative 4, then 16 minus a negative 4 is my other number, or other number is 20. So one possibility is this right here. The other one is if x is equal to, oh, wait a minute, if x is equal to 20, then if I do 16 minus 20 for my other number, I get negative 4. So those are the same pairs. So I don't really need to state an answer twice because we have the same numbers. So we just say the numbers are negative 20, or negative 4 and positive 20. And there's my final answer. Okay, let's go down to the next one. Find two consecutive odd integers such that the square of their sum is 256. Two consecutive odd, we say let x equal the first consecutive odd integer. And then consecutive odds follow the same pattern as consecutive evens. Remember, it's x plus 2, x plus 4, so let x plus 2 equal the second consecutive odd integer. Never, ever, ever, ever will you do x plus 1, x plus 3, that just never happens. Okay, so then it says the square of their sum, which means we do their sum first, x plus 2, then we square that. Is means equals 256. Simplify what's in the parentheses, and I get 2x plus 2 quantity squared is equal to 256. Okay, 2x plus 2 squared is, let's FOIL it, 4x squared, plus 2 times 2 times 2x is 8x, plus 4 equals 256. And then finally subtract the 256 from both sides, and I get 4x squared plus 8x minus, this would be 252, equals 0. Now we're going to want to take out a greatest common factor, and we can actually divide that from both sides because our right side is 0. Let's try taking out a 4. I would get x squared plus 2x minus 63 is equal to 0. And if I take this and I factor it, I would get x and x. 63 is made up of 9 and 7. And if I make that a plus 9 and negative 7, I would get x equals negative 9, or x is equal to 7. Okay, let's go with the negative 9. If x equals negative 9, then x plus 2 is equal to negative 7, and that's one of my pairs. If x equals 7, then x plus 2 is equal to 9. That's another one. So, I'm going to put it over here. The numbers are, and then one pair could be negative 7 and negative 9, or 7 and 9. We have two possibilities. You must state both for full credit. Let's go to number 3. The length of a corridor is 4 times its width. Corridor just means like a box or a hallway, so let's put this down. If I have a width and the length is 4 times that, then this little diagram acts like a let statement. I can still put let W equal the width in feet, and I'm going to put a little feet here after these so that we can see that we're in feet, but either one of those is fine. We know that area equals length times width. So if I do a substitution, area is 121, put that back up there, length is 4W, and width is W. Then what I get is 121 is equal to 4W squared. Set it equal to 0 in factor, so 0 is equal to 4W squared minus 121. And if you look at the factoring pattern, this is a difference of 2 squares. So separate it into two binomials. I have 2W plus minus 11 and 11. And then this is 2W equals negative 11. W is equal to negative 11 over 2. This is going to be W is equal to positive 11 over 2. Width can't be negative, so I know that W is equal to positive 11 over 2. We're going to state that as a decimal. The question asks what are the dimensions, so let's figure out what 4W is. If W equals 11 over 2, 4W is equal to 4 times 11 over 2, which is 22. So I can say the dimensions are 11 over 2 is 5.5 by 22 feet. Last one, the width of a rectangular playground. Let's draw another rectangle. Width is 4 more than 1/3 of the length. So I'm actually going to take this statement here and I'm going to translate that. Width is 4 meters more than 1/3 of the length. So what I actually want to do is say let L equal the length in meters if I was to do a let statement. And if I'm not going to do a let statement, I'm going to put L as the length, but then we're going to take 1/3 L plus 4 as the width. So L is our variable here. And it says area is 3060, so same thing, 3060 equals length times width, and this is what we're solving. Best way to solve this, let's simplify the right side. 3060 equals to be 1/3 L squared plus 4L. And then if I multiply both the left side and the right side by 3, I get rid of the fractions. 9180 equals L squared plus 12L. So then I have 0 is equal to L squared plus 12L minus 9180. So we now have to factor this. I have L and L, and I have to figure out how do I factor 9180. Well, I know that 9180 is divisible by 9, and it's divisible by 10, which means it's also divisible by 90, because it's divisible by 9. Now, how do I know it's divisible by 9? Well, sum of digits. If I take a 9 out of that, I get 1020. And then if I take a 10 out of that, I get 102. So 102 times 90 works. Now, it just so happens that 102 and 90 are 12 apart, and that's going to work for our factoring, so let's go put them there. There are methods to get to that, trial and error, but when I looked at 9180, it spoke 9 to me, and it spoke 10, so that happened to work. Then we have plus 102 minus 90. This is going to be L is equal to negative 102, which doesn't work because it's a negative number, and it should be a length. This is L is equal to 90. So if I look back at the question and it wants the full dimensions, if L is equal to 90, then let's plug that back in. 1/3 times 90 plus 4 is 34. That's the width. So the dimensions are 90 by 34 meters. If I go back to my figure, I should probably put meters in parentheses here, just to make sure that the units are there. And that's it.